Professor Pelton, this is Algebra 2, Chapter 5, Section 5. This is performing function operations. We're on page 3 of the notes. Okay, so for this example we're going to multiply, and the next example we're going to divide two functions. So here we want f times g of x. You don't necessarily need to put the dot in between, that's up to you. So this is x squared times root x. So we have one in exponent notation, one in radical notation. Need to convert them to one or the other. Convert to exponents. That's x squared times x to the 1/2. So using the product rule, we need to add these things. So let's see. 2 is really 4/2 times 1/2. So that gives me x to the 5/2 is the actual product of the two functions. So that is our actual function. Okay, so next thing we need is the domain and the range of this function. So we got to think about what we cannot be, not what we can be. There's infinite things we can be. What can't we be here? Is there a denominator? No. Is there a even root? Yes, there is. Because if you rewrite this, this is the second root of x to the 5th power. Second root is an even root. That means you cannot plug in negatives there. So you can be 0 to infinity. I can't get to infinity. But the question is, can I plug in 0? Yes, you can. You can be 0. That's fine. Okay? Alright, so for the range, okay, plug them in. If you plug in 0 into the problem, right, what do you get? You get 0 square roots to the 5th power, which is 0. Okay. If you plug infinity, what do you get? You get infinity, right? Square root of infinity is infinity, 5th power, still infinity. So the domain and range are essentially the same in this case. Is that always true? No. Okay, so once it's a specific example of when x is 9, what is the coordinate for this graph? So f times g of 9 gives us 9 to the 5/2, which essentially is the second root of 9 to the 5th power. So the square root of 9 is 3. 3 to the 5th power is 243. So f times g of 9 is 243. Thus 9, 243 is a coordinate on this graph if we were to graph it. Okay, so we're saying 0 to infinity for domain and range for x to the 5/2 power. Let's check that out on the graph, see what that actually looks like. So graph x to the 5/2 power, enter, and looks like that's actually true. So domain, we go 0 to infinity, and range we go 0 to infinity, so I think we're fine there. Okay, let's try the next problem, which is division. Okay, so in this case we have f divided by g of x. So we have 6x to the 1st power over 2x to the 3/4 power. So this looks like a quotient rule, correct? So we need to make common denominator, 6 over 2. So that's x to the 4/4 over x to the 3/4. So f over g of x equals 6 divided by 2 is 3. Quotient rule over exponents says subtract, so 4/4 minus 3/4 is 1/4. Okay, so 3x to the 1/4. Okay. So, domain and range. Domain and range. Alright, so the question is, do I have any denominators, and do I have any radicals that are even? In this case I have both, so I guess I have 3 times the 4th root of x, which means, again, since it's 4th root, can't be negative, so I'm going 0 to infinity. However, I also have the denominator here, and I can't plug in 0 there, so I can't be 0, and I can't get to infinity. And if I plug those in, I'm going to get the same outcome for range also, of 0 to infinity. Okay? So for the specific example, we want 16 this time for the specific example. So f over g of 16 is the 3 times 16 to the 1/4, which is 3/4 roots of 16, which is 3/4 roots of 2, 2, 2, 2. 4 times 4 is 16. So we get 3 times 2. So the answer is 6 for f over g of 16. Okay, so there is a point 16.6 specifically on this graph if we were to graph it. So let's graph 3x to the 1/4. Okay, so menu, graph, function, 3 times x to the 1/4, and very similar to the other one as it goes to 0 to infinity, 0 to infinity, but not including 0 in this case. Okay, pause the video, try the student problem for yourself. Alright, so for the student problem, we have to do multiplication and division. So we'll do f times g here. Okay, so we have 15x times 3x to the 1/5. And over here we'll do the division, which is f divided by g of x, which is 15x over 3x to the 1/5. Okay, so product rule of exponents, we have to add. Oh, we never put the x over here. I'm going to put that in, don't we? This is improper notation. F times g of x. F times g of x. Okay, so let's see. 3 times 15 is 45. And this is really 5/5, which is 1, right? So that gives me, I'm going to add them 6/5. So that's our function there. Okay, so go over to here. F over g of x equals 15 divided by 3 is 5. So again, that's 5/5. Quotient rule says subtract, so 5/5 minus 1/5 is 4/5. So there is our function. Okay, so we need to do domain and range. Input and output. Domain and range. Okay, so are there any restrictions on the input? Are there any denominators or even roots? Well, no, because this is 45/5 roots of x to the 6th power. So that's an odd root. I can plug in anything I want. There's no restrictions. Same thing here. This is 5 times the 5th roots of x to the 4th power. Since it's a 5th root, there's no restriction. This is what I can plug in. However, are there any restrictions on the output? Okay. Well, hold on. We have the denominator here, don't we? Right? So 3x to the 1/5 cannot be 0. So if I divide by 3, x to the 1/5 cannot be 0. So I do the 5th power, x cannot be 0, correct? So therefore there's a hole in our domain here. As a result, I get negative infinity to 0, union 0 to infinity. Okay, so if we plug these in now, what is the output? If I plug in negative infinity versus positive infinity, what happens? Okay, so whether I plug in positive or negative infinity, the 6th power is going to force this to be positive. Times 45 is still a positive number. Therefore, I can't get a negative number. These are always going to positive infinity. So the question is, what is the smallest number I can get? Well, again, what's the smallest non-negative number? That's 0. So the 5th root of 0 to the 6th power times 45 is 0. So it's going to go to infinity, but the lowest I can get is 0. But I can be 0. Okay? Versus range over here. Again, if I plug in negative infinity or positive infinity, it doesn't matter. because the fourth power is going to force this to be positive. So therefore, I cannot get a negative number on the output. So the question is, what's the smallest thing I can get? Well, if I plug in 0, I can get 0, but that's not an applicable input. So this is 0 to positive infinity, but not including 0 on this one. It does include 0 here, hence why we use the brackets. Okay. Now we'll do these specific examples. In this case, they want us to try 32. So f times g of 32 equals 45 fifth roots of 32 to the 6th power, which is 45 times 2 to the 6th, which is 45 times 64, which is 2,880. Therefore, 32,2280 is a coordinate on this graph, or one of the coordinates on the graph. So over here we try 32 also. So that's f over g of 32 equals 5 fifth roots of 32 to the 6th power equals 5 times 2, that's the 4th power, I'm sorry, not the 6th power. The previous one was 6th power. This one is 4th power. So that is 5 times 16, which is 80. So that means 32, 80 is a coordinate on this graph if we were to graph it. Okay? Alright, so let's try graphing one of these. We'll do the 45 x to the 5th power. Okay, so menu, graph, function, 45 times x to the 6/5 power. So it should be very similar for both graphs. And as you can see, okay, it's this one here. It's close to the y-axis. It will not go into the negatives in either one, left or right, or up or down. It's just going 0 to infinity, including 0. Okay?